Let's revise what we've learnt about levers so far. We have here a plank, which will be the lever, a load, and I'm using this pipe as a fulcrum. Let's have a look at this in close-up. To show all three classes of levers, all I need is a piece of plank to act as a lever, something to act as the load. I will provide the force, and we're going to use this round pipe as a pivoting point. The first class lever is pivoted in the middle. So we have the load on one end, I apply the force on the far end, and the pivoting point or fulcrum is in the middle. Now, key points here, if I push down on the effort side, the load goes up, and that is characteristic of a first class lever. The load moves in one direction while the force is applied in another direction. Can I get mechanical advantage with this? At the moment there's no mechanical advantage because this is pivoted approximately in the middle, but if I move it like that, it's still a first class lever because I'm pivoting between the load and the effort, so my pivoting point is there. But now, because I have given myself a nice long lever to work with, and I have given the load only a short lever to fight me with, I have a mechanical advantage, and I will be able to lift this load very easily like that. Small force here is going to lift this much heavier item over there. Now let's have a look at a second class lever. Same pieces of equipment, the difference being I now need to move the fulcrum or the pivoting point to the end of the lever. I need to place the load in between the fulcrum and the end where I'm going to make the effort, and in this case we have what is known as a second class lever. Key characteristics: if I push up, the load also goes up. So in the second class lever, the load and the effort happen in the same direction. With the first class lever, the load went up when I pushed down. Here I have to lift up in order to make the load go up. Do I get a mechanical advantage with a second class lever? Yes, I do, because again the load has a small piece of plank to assist it, but I have the full length, so I've got much greater leverage than that, and I will be able to lift that. And you'll recognize that this is the same system that we have with a wheelbarrow. How do I make this into a third class lever? Well, the third class lever is characterized by the load being at one end and me making the effort in between. So if I lift over here, I'm going to have a third class lever. Now, please note the first class lever, let's just sum that up, pivoting in the middle, load on one end, effort on the other. Second class lever, pivoted on the end, load in the middle, effort on the end. Third class lever, load on the end, pivoted on the other end, and I make my effort in the middle. Do I get a mechanical advantage this time? No, I don't. In this case, the load has the full leverage and I only have half the leverage. So the load has the advantage, I have the disadvantage. Now, why would I want to do something like this? Well, I'd want to do this if I wanted to lift something at a distance. I'm going to sacrifice my force advantage that I get with the first or second class lever and get a distance advantage. With first and second class levers you have a force advantage and a distance disadvantage. With a third class lever I have a force disadvantage, but I compensate for that by having a distance advantage.